So in this next little module, we're going to talk about how to use that law of total probability, which I just discussed, to calculate some conditional probabilities for Mendel's P's. Now, in the scenario in which you basically set up a cross of parents of known genotype, for example, this cross here, or selfing, for example, between big R and little r. Well, we've already determined how to calculate the probabilities that you get a round P or a wrinkled P. But sometimes it's not so simple. What we want to do, for example, is suppose you set up this particular cross, okay, and you collected a plant with round P's, okay, and then you cross that one to a plant which had this genotype and therefore produced wrinkled P's. We could ask this particular question, so this is the F1, okay. We could ask, what is the probability that the F2 would have wrinkled P's? Now, how do we figure that out? Well, let's think this through for a minute, okay. What is that genotype? Well, we already kind of know that, well, it certainly can't be little r, little r. Well, we actually can calculate these things conditional on what we think the probability of this individual has a particular genotype. For example, the only possible ones are this one or this one. Okay. The likelihood or the probability that this particular outcome occurs depends on the probability or condition of this or this. Okay. What is the chance that in fact you would actually produce a wrinkled P-bearing plant from this genotype crossed with this genotype? Well, it's none, right? Because this will pass on either this copy or this copy, so all of these progeny would then be big R, little r. This is called a test cross. So let's actually break this down a little bit more formally. So what we want to know is, in this scenario, what is the probability, I'm going to get rid of this, okay, what is the probability that the F2 is of this particular genotype, little r, little r. Okay. And what I'm going to do is I'm going to basically break that down into two conditions. Using the law of total probability, I'm going to say that that's going to be equal to the probability that the F2 ends up equal to little r, given this individual is in fact big R, okay, times the probability that this individual is big R, okay, plus, okay, using the law of total probability, the probability that the F2 is equal to little r. Now, given the condition of big R, little r, comes the probability that this individual here is big R, little r. So actually, this is actually going to be the case. And now, of course, because we know that that individual was round P, we know that that individual that I just showed there was not little r. So the probability that I talked about here, the probability that the F1, okay, is equal to big R, okay, plus the probability that the F1 is equal to big R, little r, big R, and big R, little r. We know that these add to 1, right, because of the law of total probability. So we can do this. And we can decompose the scenario in which the F2 in fact produces wrinkled P through all the different mutually exclusive ways or paths, in a way, that you can get to this particular case. So now we need to calculate some of these probabilities. Okay. So let's figure them out. Let's start plugging these numbers in. Okay. Well, what is the probability that, in this particular case, so I'll just show it one more time. Okay, it's crossed together. It's the F1. This gets crossed to little r, little wrinkled bearing plant, of course, and the F2. What is the probability of producing a wrinkled one? Well, given that this individual, suppose, is in fact of this genotype, we know that that's not going to happen because the only type of possible outcome of this particular cross is that genotype. So what we can do is, up in this thing here, we can put a big fat goose egg. 0 goes in there. Now, what's the probability given that this individual, in fact, is heterozygous, that we get a wrinkled P? Well, it's 50-50, right? Because the way in which it would happen is this always will transmit this allele, and it's 50-50 by which you either transmit that allele from this individual, okay? So here, the chance is 1/2. Now, there's another tricky secret part of this problem that I haven't really shown you yet. In fact, you think you might know these things. You might think, oh, well, this is simply 1/4, right? The probability of this being big R here, this individual here. You might think as well, that's just sort of the Punnett square. So this is 1/4, and the probability that this individual is in fact, 1/2. Okay. Well, that's not quite right. Okay. And the reason for it is going back to the Punnett square. We've already ruled out that that possibility cannot be, in fact, r. So F2, okay, the probability that the F2 is in fact equal to r, okay, that is equal to 0 because it has round p's, okay. So going back to the Punnett square, okay, where we talk about big R, little r, okay. Well, in fact, of the total possible ways, this way is blocked out. Okay. So now of the domain sort of taking up 4 squares is actually the domain of total probability is in fact taking up 3 total squares, okay? And this individual is of this genotype, this individual is of this genotype, and this individual is of this genotype. What fraction of the sort of domain of total remaining probability corresponds to this? Well, it's actually 1/3. Okay, so this is a 1/3 chance of this. Okay, and in fact, what is the domain of the total realm of possibility corresponding to the individuals being heterozygous? Well, of course, that's equal to 2/3, right? And remember, I said that the probability of all of these would have to add to 1, and because this is equal to 0. Okay. So that's it. I mean, that's it. And if you think about this for a second, it kind of makes sense. Okay. So what's the probability that in this particular cross, okay, you end up with a wrinkle-bearing plant? Well, there's no way it's going to happen in this particular case. So it's 0 times 1/3. So this is equal to, up here, this whole thing is equal to 0 times 1/3. Okay. Plus, okay, the probability that you actually do in fact end up as heterozygous, okay, which is equal to 2/3, times, given that you are in fact heterozygous, the probability that you do transmit the r allele to make this individual homozygous, whether that's a wrinkled allele, and this will then of course be 1/2. So in this particular case, 0 times 1/3 plus 1/2 times 2/3 is equal to 2/6, which is equal to 1/3. So that is the probability that you end up with a wrinkled P after going through this scenario. And what I've shown you is I've taken advantage of this law of total probability and these conditional statements to determine what that is. You can do this for all sorts of things.